When I was 10, I saw my first galaxy through a cracked school telescope. The science teacher turned off the classroom lights, opened the roof of the tiny observatory, and let the night pour in. Above us, the cosmos looked like someone had spilled milk across a black table. Out there, he said, pointing, is a universe so big you cannot imagine it, but you can measure it, question it, and explore it. That's what astronomy is for. At the back of the room, someone giggled and whispered, "My aunt says astrology can tell the future from the stars." The teacher smiled. "Astronomy is a science," he replied. "Astrology is a story people tell themselves. If you want truth, learn to read light, not horoscopes." I didn't fully understand, but the words stayed with me. That night, walking home on our quiet, terrestrial street, I watched the moon glow above the rooftops. It felt both ordinary and celestial, like a lamp hung just for our little town. I promised myself I would leave this small world one day and touch that distant light. Years later, an official envelope arrived in my mailbox. Inside was a single page with a red stamp. Interstellar Exploration Program Crew Selection. Candidate: Lian Kiei Roll, Mission Astronaut. My hands shook so hard I almost dropped it. The girl who once stared at a blurry spiral in a school telescope was being invited to walk into it. Our spaceship was called Aurora's Question. It was not elegant from the outside, more like a stack of boxes hastily taped together, but every module had a purpose. The command deck connected to the habitat ring, the ring to the laboratory, the lab to the engine block, where the propulsion systems waited like coiled dragons. Cables, pipes, and panels formed a maze of silver veins. Behind each metal wall, a hidden circuit carried power. "Never forget," our chief engineer said during training, tapping a panel near the communications array. "This little antenna is your voice in the void. If its frequency drifts, Earth becomes a ghost." We studied the dynamics of flight until numbers danced in our dreams. How pressure changed in the tanks, how every tiny adjustment in thrust altered the ship's motion. How a small error in the navigation method could grow, like a curve that slowly bends until you miss your target by 1,000,000 kilometers. Most nights I floated by the window and watched our planet shrink. The oceans turned from deep blue to a shimmering marble swirl. Clouds became faint brushstrokes. Our terrestrial home, with all its oceans and forests and cities, slowly transformed into a single glowing specimen in the Museum of Space. Beyond it, the spectrum of stars thickened, the cold red glows of dying suns, the blue-white sparks of newborn ones. It felt as if we were leaving a two-dimensional map and entering a deeper dimension, one where every point of light had distance, history, and secrets. Our target was an ancient comet, catalogued as QZ73, drifting on a lonely orbit that crossed the plane of the ecliptic like a tilted question mark. From a distance, the comet looked small, just a moving star with a faint tail, but the mission files said otherwise. Its diameter was nearly 30 kilometers, its radius a frozen vault filled with information older than Earth's earliest continents. "This isn't just exploration," our captain said in the mission briefing. "It's an expedition into time. Some of the ices in that substance have not melted since before our planet formed." We approached cautiously, letting the ship perform a slow flyby first. Our sensors traced the curve of its path, measured its spin, modelled the composition of its coma, the glowing cloud, the so-called envelope of gas and dust that surrounded its icy chunk of a core. On the external cameras, the comet was a floating spectacle. Jets of vapour burst from vent-like cracks, forming fountains of ash and ice. The tail streamed out behind it, a luminous river pointing away from the sun. In the lab, I watched as the onboard probe warmed up. Soon it would detach from the spacecraft, descend to the comet's surface, and anchor itself with harpoons. On the projected map, our landing zone sat near a dark crater, where models suggested ancient materials were exposed. 15 hours later, the probe launched. On the main display, it shrank into a tiny dot, gliding toward the grey world, a piece of human curiosity crossing the void. When the first sample arrived through the collection system, it didn't look like history. It was just a small chunk of dirty ice sealed in a transparent sphere, rotating slowly under lab lights. Frozen dust glimmered inside it like stars trapped in glass. "This is it?" I asked. "The treasure of the universe?" "Treasure rarely looks like treasure," replied Dr. Hain, our lead scientist. "Let's see what it's made of." We heated the sphere carefully, turning the solid ice into liquid, then into vapor. Instruments captured every escaping particle. We measured each molecule, each atom, each ion that broke free. Detectors registered the dance of every freed electron, tracing how they jumped between energy levels in tiny quantum leaps. "The composition is complex," Hain said, staring at the readouts. "Multiple organic compounds, amino acids, carbon chains. This is more than a rock. It's a story." Another device examined the released gas as a fluid, tracking how it flowed and spread in microgravity. We watched the changing spectrum of emitted light as the vapor cooled. A rainbow barcode recording the substance of the comet's heart. Then came the real surprise. A separate chamber slowly warmed a thin slice of the original ice, preserving its internal formation. Under magnification, we saw delicate patterns, spiral ridges, and branching filaments, like something that had once grown and then been frozen mid-breath. "It can't be," I whispered. "Are those?" "Not bones," Hain said softly, "but structures. The closest analogy we have is a fossil, a shape left behind by something that once lived or almost lived." We captured thousands of images. Each one looked like a frozen thought from a mind that never quite became a world. The more we studied, the stranger the comet became. In one experiment, we arranged tiny fragments of ice and dust in a magnetic trap, watching how each particle moved in response to controlled fields. To our surprise, the paths were not random. They traced repeating patterns like letters from an unknown alphabet. Hain frowned. "This is not natural." "Careful," I said. "We've called many things natural, or unnatural, just because we didn't understand their dynamics." He nodded, then adjusted the controls. The particles shifted, forming shapes that reminded me of branching trees, then spirals, then geometric curves that matched known mathematical ratios, the same radius and diameter relationships we use to describe circles, orbits, waves. "It's as if the comet is running a simulation," I murmured, "like a laboratory that has been experimenting for billions of years." We tested another specimen, this time exposing it to different pressures and temperatures. Again, the patterns emerged, as if the material were trying out new solutions, new ways to synthesize complexity from chaos. "Maybe this is its method," Hain said. "Not a message to us, but a process. A long, patient search across time and dimension, exploring what is possible when atoms dance together." Later, floating alone near the observation window, I looked out at the galaxy again. It no longer felt like a silent sea. With every flyby, every comet, every meteorite that had struck our world and carved a new crater into its crust, the cosmos had been running experiments, testing combinations of substance, compound, temperature, and light. Perhaps life was not an accident, but a pattern that kept trying to appear like a faint signal buried in noise. On the final week of our mission, we deployed a ring of small sensors around the comet, like a bracelet of artificial moons. Each carried its own miniature antenna, circuit, and propulsion unit. Together, they formed a moving observatory, orbiting the frozen body in a synchronized dance. We pulsed radio waves through the system, sweeping across a wide spectrum of frequencies. The returning signals revealed hidden cavities beneath the surface, reservoirs of trapped liquid and ancient gas, pockets where fluid currents once flowed before freezing in place. When we mapped the results, the internal formation of the comet looked eerily familiar, layered, branching, organized, like the neural structure of a sleeping brain. "Look at this," Haynes said, overlaying additional data. Temperature gradients, chemical composition, pressure zones. If you treat the whole comet as a single enormous experiment, it follows a kind of logic. Inputs, outputs, feedback loops. A cosmic laboratory, I whispered, or maybe a seed. Our captain joined us at the display. A seed for what? We had no answer. Maybe for worlds, maybe for minds, maybe for stories like ours, told by beings who wondered where they came from. As Aurora's question prepared to depart, I recorded my final log for the mission. We came here seeking rocks and ice. We leave with questions about universe-scale exploration. This expedition has shown us that the line between solid, liquid, and fluid, between chemistry and life, between random motion and deliberate pattern, is thinner than we thought. In every molecule, every atom, every shifting electron, the quantum rules of reality quietly sculpt possibility. In the distance, stars shimmered, each one a potential laboratory, each system a new arrangement of orbit, ecliptic, and light. Our job, I concluded, is not to control the cosmos, but to listen. The frequency of its voice is faint, spread across time and space, but it is there, humming through every circuit of matter and energy. We are only at the beginning of learning how to hear it. We fired the engines. The ship's propulsion system roared softly through the hull, a low, comforting vibration. Our trajectory bent, a gentle curve away from the comet, back toward our small blue terrestrial home. As the comet shrank behind us, its glowing tail stretched like a thin, silver line in the dark, a punctuation mark at the end of one chapter in the long, unfinished story of the cosmos.